Time. It shapes our lives, defines our memories, and drives every clock in the universe. But where did it come from? Is time an eternal backdrop? Or did it somehow emerge, perhaps even create itself? Today we'll explore what physics says about the origin of time, from Einstein to entropy, quantum gravity to timeless universes, and ask a bold question: does time create itself? Or is it just an illusion? Before Einstein, time was simple. Isaac Newton believed in absolute time, a constant flow independent of space, motion, or observers. It was like a universal clock, ticking the same for everyone, everywhere. But Newton's time had no beginning and no end. It just was. In that worldview, the idea of time creating itself doesn't even arise, because time is eternal. But this concept was shattered in the early 20th century. In 1905, Albert Einstein's special relativity showed that time is relative. It slows down depending on your speed. Later, with general relativity in 1915, Einstein introduced the idea that space and time are unified, forming a four-dimensional entity, space-time. Mass and energy warp this space-time, and that curvature affects how time flows. This is why time passes differently on Earth than on a GPS satellite. This isn't theory, it's measured and corrected for every day. Here, time isn't an independent thing that creates itself. Instead, it emerges as a property of the geometry of the universe. Time flows differently for different observers depending on gravity and motion. It's no longer universal and certainly not absolute. But what about time's direction? Why does it always move forward? This is the arrow of time, and it's governed by the second law of thermodynamics. In an isolated system, entropy, or disorder, always increases. That's why you remember the past, but not the future. It's why stars burn out, ice melts, and the universe expands. Entropy gives time its irreversibility. But here's the mystery. The laws of physics are mostly time-symmetric. They don't care if time runs forward or backward. So why did the universe start in such a low-entropy, highly ordered state? Some physicists argue that the initial conditions of the Big Bang are what set the arrow of time. Without entropy increasing, we might not experience time at all. So in this sense, the flow of time is conditional, not fundamental. Modern cosmology traces time back to the Big Bang, about 13.8 billion years ago. At that point, space, time, energy, and matter all emerged together. Before the Big Bang, the concept of before may not make sense, because time itself might not have existed. Stephen Hawking famously said, "Asking what happened before the Big Bang is like asking what's north of the North Pole." But did time begin there? Or is there more to the story? This brings us to quantum cosmology, where things get truly strange. One of the most well-known models is the Hartle-Hawking no-boundary proposal. It suggests that the universe began not with a singularity, but as a quantum wave function. In the very early universe, time behaves like a spatial dimension. There's no clear before or after. Only as the universe expanded did classical time emerge. In this view, time is not fundamental. It emerges from a timeless quantum reality. Other quantum gravity theories, like loop quantum gravity, propose that space-time itself is quantized, made of discrete units. In such frameworks, time isn't a continuous flow, but a statistical behavior that emerges from interactions between quantum states. String theory and holographic models like the ADS-CFT correspondence also suggest that time may not be a core ingredient of reality, but a secondary phenomenon emerging from more fundamental structures. In fact, many physicists refer to this mystery as the problem of time. In quantum mechanics, time is a fixed parameter. In general relativity, time is dynamic and flexible. Trying to unify the two leads to contradictions. Some equations describing the universe at its most fundamental level, like the Wheeler-DeWitt equation, don't include time at all. This has led some researchers to propose that time is not real. Instead, it's a psychological or emergent illusion created by the way we process change. One striking idea comes from physicist Carlo Rovelli, who suggests that time is ignorance. What we perceive as the passage of time may reflect our limited knowledge of the full quantum state of the universe. So does time create itself? Not exactly. Time, as we experience it, likely doesn't exist at the deepest level of reality. It emerges from entropy, from quantum states, from the geometry of spacetime. It's not a cause, but a consequence. And that's what makes time one of the most profound, beautiful, and unresolved mysteries in all of science. If this journey through time blew your mind, subscribe, and join me for more deep dives into the universe's biggest questions. You're watching Infinite Narratives, where we explore science, space, and the edge of what we know. See you again.